I think I am live now. Can anyone confirm if audio and everything is fine before we get started? So, like, I was able to solve all problems, so naturally, I would be discussing all the problems. And yeah, like, if you prefer text or tutorial or something, you can check out my this blog where I have provided the hints of the problems. And like people in the chat, like, how many problems were you guys able to solve today? Like, this will give me some idea on which problems to focus more and which we can probably move faster. Okay, two, three, two, three. I think most of the people solve two and three problems, but yeah, I think let's get started now. First problem says Robin helps. Robin encounters n people starting from the first and ending with the nth. The ith person has AI gold. If AI is greater than equal to k, Robin will take all AI gold. If AI equal to 0, Robin will give 1 gold if he has any. Robin starts with 0 gold. Find out how many people Robin gives gold to. So the idea would be same, like we would maintain two counters. One of them would be like to how many people Robin has given gold, and one would be how much gold the Robin has. So then the idea would be like whenever he encounters someone with greater than equal to k gold, he will increase his gold quantity by AI. If he encounters someone with AI equal to 0 and the amount of gold Robin has is at least 1, then we will give that 1 gold to Robin and decrease our counter by 1. And we will also increase the number of gold people we have given gold to by 1. And at last print the counter we have. So two values, first read all everything as input. How much gold Robin has and how many people Robin has given gold. Now iterate in increasing order. If x is greater than equal to k, all the gold we have right now, Robin will snatch it. If x is equal to 0 and we have at least 1 gold, we increase the gold by 1, we increase counter by 1, and at last we print how many people we have given gold to. This solves the first problem. I will probably move on to the second problem now, and in case any questions are there on the first problem, I would be happy to help out after I'm done discussing the second problem. Major oak grows I to the power I new leaves in the ith year. He starts with one leaf in year 1. Leaf lasts for k years on tree. In other words, leaves grow in year I, last between year I and I plus k minus 1 inclusive. Robin considers even number lucky. Help Robin determine whether major oak will have an even number of leaves in the year n. So let's see what is happening over here. Like let's probably just take 3 n equal to 7 and k equal to 3 test case. On the first test case, we will have 1 to the power 1 gold. Second day, new loose would be here. Or probably let's put it like that. Day 1, day 2, day 3. Day 4, day 5, or probably just day 3, day 4, day 5, day 6, and day 7. Like every leaf lasts for the first day. So on day 1, we will plant one leaf and it will last for these 3 days. On second day, we would plant 2 to the power 2 trees, which would be 4, and it will again last for 4 days. On the third day, we will plant 3 to the power 3 leaf. On the fourth day, we will plant 4 to the power 4 leaves. On fifth day, we will plant 5 to the power 5 leaves. On sixth day, we will plant 6 to the power 6 leaves. And on seventh day, we will plant 7 to the power 7 leaves. And this is what we need, right? We have to print whether this value is odd or even. So one thing you can notice over here is like only leaves planted between n minus k plus 1 and n will remain. Like everything before it will be like will die out before we reach the end. Next thing to notice here was k to the power k is odd if and only if k is odd, and k to the power k is even if k is even. And what we really need is like how many days between n minus k plus 1 and n we planted odd number of leaves. Odd leaf or plant, whatever we call odd plants. If this count is even, then the answer is even. If this count is odd, the answer is odd. So like the problem reduces to counting whether how many odd numbers are there between n minus k plus 1 and n. Now what we can do is like number of odd numbers. We can first see how many odd numbers are there. Up to 1 only odd number is there. 1 odd number is there. On day 2 also only odd number would be there. Like because 2 is even. On day 3 1 and 3 both would be. Up to day 3 like we will encounter 2 odd days. 4 is even, so only 2 odd days. Up to day 5 from 1 to 5 numbers we will have 3 odd days. 1, 3 and 5. For 6 also we will have 3 odd days. For 7 we will have 4 odd days and so on. So you can notice is like number of odd days between 1 and k is k divided by 2 and take C if required. And like essentially that is the solution. To count number of days from 1 to k up to n, like first we can count how many days from 1 to n are there with odd count, and then we count how many days up to n minus k are there, and difference of them is essentially what is the odd count between these days, and then we can check if this odd count is even and odd and then print yes and no accordingly. So I have this function which takes a day and gives us how many days from day 1 to up to day n would be an odd day, which is essentially ceil function over here. You can probably write it using true if else as well. Total number of days when we planted odd days minus total number of already expired days. If total number of days with odd count is 0, then the answer is yes, otherwise the answer is no. And essentially this ends up being the solution for problem. Any questions on the first two problem before we move on to the third problem? Yeah, like sum is another good way to do it. Like you can also find the sum of days from 1 to n and do it as well. Moving on to problem C. It says there are n people living in the town. Just now the wealth of ith person is AI gold. But guess what? The richest person has found an extra pot of gold. More formally, let Aj equal to maximum of A1 to n. Change Aj equal to Aj plus x, where x is a non-negative number of gold found in the pot. If there are multiple maxima, it can be any one of them. Like you have to use sum of like numbers from 1 to n direct formula, not running a for loop from 1 to n. You can use sum of AP formula. A person is unhappy if their wealth is strictly less than half of the average wealth. Strictly less is a bit important. And if strictly more than half of the total population are unhappy, Robin will appear by popular demand. Determine the minimum value of x for Robin to appear or output -1 if it's impossible. There are multiple things over here. First, this, like what is the average we have? Let S be the sum of AI plus X the gold we have found. The average would be S by N, and like more than half of the people are unhappy. Like so, we first need to find what is the minimum number of people that should be unhappy. So if there is just one person, half of 1 is 0.5, more than half is 1, unhappy count. Half of 2 is 1, more than half is again 2. So like in case total people is 1, one person should be happy. In case there are 2 people, both of them people should be unhappy. And like these would be the impossible cases because richest person is always happy. Average is always more than equal to the largest number. Now if we have 3 people, half of 3 is 1.5, so we want 2 unhappy people. Half of 4 is 2, so we want 3 unhappy people. Half of 5 is 2.5, so we want 3 unhappy people, and so on. So if we sort all AI, let's say we have number n and we want k unhappy people. So let's sort AI and look at kth smallest number. Right? Like that's what we want. A person is unhappy if strictly less than half of the average wealth. So like the amount of money kth person has should be less than average by 2. So now let's try to simplify this formula. Let's write what is average. Average is initial sum plus x by n and again 2. Now in this equation, let's move this on this side. We will get 2 into n into ak is less than s plus x. And let's move s as well. So we will get 2 into n into ak minus s should be greater than x. Okay, problem specifically says that the average can be a real number. So if average is 3 by 2, then it is more than 3 obviously. And we also want that x should be greater than equal to 0. So like the smallest number, first let's find this value. Let's say this value is 5. Then the smallest value which is less than 5 would be x equal to 6. Or if this value is let's say 20, then the smallest value which is greater than 20 would be x equal to 21 and so on. And this is the main idea here. So like bit mathematical manipulation was required over here, and essentially that ends up being a solution. Any questions on this problem? Read everything. If n is less than or equal to 2, directly print -1. Unhappy count we really need is n plus 2 by 1. So, which that ends up being our k. AK would be the kth smallest number, which is k minus 1. And then our sum would be AK into 2n minus sum plus 1 and whatever is the mean. Yeah, if x is less than 0, we should print. You can definitely use binary search, but that's strictly not required. So like, don't use binary search just for the sake of it, is all I have to say. Like binary search would be on x, you start with some low, you start with some high. Whatever is the mid, you add mid to the largest number and then check what is the average and what is the k therapy, how many people are less than half of the average and how many people are less than the average, and take it to the k by 2. Probably not the best problem to learn binary search on. So this was the third problem. Any questions on the third problem before we move on to the fourth problem? Okay, moving on to the problem. So 1 second. Robin's brother and mother are visiting. Robin gets to choose the start day for each visitor. All the days are numbered from 1 to n. A visitor stays for d continuous day. All of those d days must be between 1 and n inclusive. Robin has a total of k risky jobs planned. The ith job takes place between Li and Ri inclusive. If a job takes place on any of the d days, the visit overlaps with his job. Robin wants his brother's visit to overlap with maximum number of distinct jobs and his mother the minimum. Find the suitable start dates for visit of Robin's brother and mother. If there are multiple suitable days, choose the earliest one. So the first thing we want is, like, notice that all the days are between 1 to n and sum of n is up to 2e5 only. So let's just count for each day how many jobs it overlaps with. By the way, it should also, problem should, okay, k is less than or equal to n is also given to us. And once we know, like, for each day how many jobs it overlaps with, we can then take a look at, like, which day to choose by running a for loop for finding both maximum and minimum. And in case there are multiple equal days, we can also choose the other one. Okay, so this would be the main idea for us. And like the way we will find the number of days for a particular day I is to use two pointers. One second. One second. Yes, D is sliding window. One second. Like I have in fact changed the nib as well. For each day, let's find overlap count. Once we know this overlap count, we can find the answer. Like there are many ways. One way is you can either use a sliding window, or you can probably use some difference array prefix sum etc. sort of thing. The way I will do is some prefix like sliding. I will show you the sliding window technique. So like let's first take one of the example. Let's say this is the example. One job is between day 1 and 3. One job is between day 2 and 3. One job is between day 4 and 8. And one job is between day 7 and 9. Robin works for let's say 2 days at a time. Then first we will start with one pointer here and we will see how many jobs overlap between 1 and 2. And we will put these two values into the queue. Then we will move a bit further to 2 and 3. Nothing will change. No new jobs have came up here and no new job we had left over here. Then we will move to 3 and 4. Here we will have one more overlapping job. So we should probably put it in a queue or something. Then we will move a bit to 4 and 5. In this case, now we have left two more jobs from here. So we should reduce our current count by 2. So on day 1, like here the overlap count is 2. Here also the overlap count is 2. Here the overlap count is 3. Here the overlap count has become 1 again. Then we will move to 5 and 6. Nothing has changed over here, no new job we have taken or reduced. Then we will move to 6 and 7. This job will come up again. So our current counter will be 2. Then we will move to 7 and 8. Our counter will again remain 2. Then we will move to 8 and 9. Counter is again 2. And then we will move to 9 and 10. The counter will become 1 because this job is no longer overlapping. And then we will move to 10 and 11. Our counter will become 0 and no more jobs we would be able to find. And this would be the main solution idea for this problem. Not sure why pen is behaving like this, but let's just continue. So probably I will jump out to the code now. So the idea is let's just maintain a set or multi-set, I would say. Current jobs and time. So I will start working from day 1 first. Like I have sorted all the numbers as well. And I cannot have overlap after n as well. So d plus d minus 1 should be less than n. As long as its index is less than k and current value is less than day plus 1. Let's increase the counter and insert the time when we will finish this job into the set. While the set is not empty and like our current jobs and time is less than our current day, like these are the already expired jobs. So let's just erase these jobs. And now like whatever is in this set is the time I would be working on. Because what I have done is when I am at the current date, I have inserted all the numbers, all the jobs which have started before before today into the set. Then I have also removed all the jobs which has ended before my current date. Like basically, whenever I am finding a new job, I add its end time into my set. And when I am moving it, like I remove all the end times which is before today from the set. And then the idea is like current overlap count would be is whatever the end time I have. Minimum value is minus infinity, let's just this. If min value is greater than current overlap, and min IDX or day is my current day. Like time complexities are same for set and multi-set. If my current value is less than the day, then I should also print the current max. Then I can print max IDX and min IDX, whatever is asked in the problem. And this would be problem D. Any questions on problem D before we move on? Yeah, this ends up being the solution for this problem. Any questions on problem D before we move on to problem E? In like for problem E, not plain dixa will not work. You will have to do something extra. One second, not sure. Like internet, why is internet a bit flaky here? Okay, yeah, accepted. I will probably move on to problem E. The travel network is represented as n vertices numbered from 1 to n and m edges. The ith edge connects vertex ui vi and takes wi seconds to travel. All wi are even. Marian starts at vertex 1 and Robin starts at vertex n. In addition, each of the n vertices have a single horse available. Only one horse is available. Both Marian and Robin are capable riders and could mount horses in no time. Travel time has half when riding. Once mounted, a horse lasts until the remainder of the travel time. Meeting must take place on a vertex that it cannot take place on an edge, and either could choose to wait on any vertex. What is the earliest time when both of them can meet? If vertex 1 and n are disconnected, that is, they can never meet print -1 as the meeting is cancelled. So, like, let's first assume like we have unlimited, not one horse, but unlimited number of horses here. Then what should be our approach here? Like our approach would be, okay, let's say we are at node 1. Let's say it takes 10 times. 2 it takes 20 times. We also have vertex 6 to 5 which will take 50 times. 5 to 4 which will take 20 times. And 4 to 10 30 times. Looks fine, right? And let's say this place has a horse. Like let's say if we have unlimited number of horses, what we can do, like we can just run a shortest path algorithm where our priority queue will contain have we found a horse, yes and no, and like if we have found a horse, we have to divide each, like our priority queue will contain time so far, node you taken so far, and we have found horse or not. Yes and no. And essentially this is all we need. Like you can just assume that all the nodes have unlimited number of horses. Like because the reasoning is, let's say from somewhere we go here, we pick a horse from here, and then we meet some another vertex here at, and if the other player is also going to come here, pick a horse and then come to here, then there is no point in going here. Like they can just meet at the place where both of them have picked the horse. And like this is the main reasoning which says us like we don't have to really care about just one horse. Just start from n, go as long as you can using Dijkstra. If you find a horse, just put some variable in diagram and saying that we have now found a HOTS, and now we should divide all the other next areas by 2. It will never be the case that both of the people will pick up HOTS from the same place and they will go to some another place to meet. What they can rather do is wherever they are picking up the HOTS, they can just wait there and meet earlier, and that would be a bit faster. And I think I realized this observation just now only, because my in context implementation is a bit more difficult than that. And this ends up being the main solution. Like, you can probably say like it's a tricky constraint, but just single HOTS doesn't really matter over here. And now the idea would be to use Dijkstra here. Like, we will have to maintain 2 variables. Like in contrast, I have done a lot of things here. Distance with HOTS and vector distance without HOTS. Let's just say this Dijkstra takes one source vertex and gives us the distance from each vertex if you reach it using a HOTS, if we do not reach it without a HOTS. I have taken all the inserted and everything into this HOTS as well. Let's maintain a priority queue. If current node contains a HOTS, then pq.push 0 distance zeroth node and we have a HOTS. Else pq01 means we do not have a HOTS. While priority queue is not empty. Let's pick the first value. Here the distance would be like, I would put negative distance into the vector. Node would be tpu.y.x and has HOTS. If we have a HOTS and if distance with HOTS to reach this vertex is less than equal to k, we should ignore this value. Otherwise, we say the best distance with this HOTS to reach this vertex is b. Similarly, if we do not have a HOTS right now, then distance with this HOTS reaching this vertex is less than e, ignore, otherwise continue. This is new vertex and weight of this edge would be this. If we have a HOTS, then we should put new value into the vertex, which would be minus d minus wei by 2, because the distance has halved. We will reach vertex 0 and we will still have a HOTS. Continue. Otherwise, if the new vertex contains a HOTS, then we will still take the same time to reach the vertex v, but now vertex v has a HOTS, or I can probably put it the other way. And if vertex V does not contain a hots, then we can say V does not contain a hots. Now we should run this from both vertex 0 and V. D1 hots, D1 without hots. Dn hots and Dn without hots. We should run Dijkstra here. Zero. First value is with hots. And the second value is given without hots. Also from n minus 1. Now what is the minimum time we will take? Started with minus 1. Meeting point, iterate on the meeting point. Time from U to 1 to reach here would be D1 with the hots or D1 without a hots. Dn also with and without a hots. Meet time would be maximum of whoever comes late, and our answer would be minimum of all the answers so far and whatever the meet time we have. If we never meet, print minus 1, the meeting is cancelled. This ends up being the solution for problem E. Any questions on this problem before we move on to problem F? Like my encounter submission is more critical, difficult than this idea. Yeah, like Shivang, I agree. Like there is one more thing, like you can, instead of using two vectors here, like this, you can just create a graph of size 2 and vertices here. Like I will show you how. Like it's possible you reach some vertex faster than taking a hot there. Like for example, you can also see this as a, let's say we have this graph from 1 to 2 with weight 10, 2 to 3 with weight 20, and let's say vertex 2 contains a hot. So you can create a similar graph. Let's call it vertex 1 with hots as vertex 1, vertex 1 without hots as vertex 2. Let's just create 2 vertex for each of them. 1, 2, 3, 4, 5, 6. Now this is when you don't have a hots, when you are on vertex 1. You will reach to vertex 3 with time 10 and vertex 2 contains a hots. So just say you reach always here. Or probably you can just say to reach from 1 to 10 without a hots it takes 10 seconds. To reach from 3 to 4 it will take 20 seconds. Similarly, if you come to 1 with the hots, you will take 5 seconds. You go from 4 to 6, you will take 10 seconds. Wherever you have a hot, you also create an edge with weight 0. And like that would be the idea. Like you can create a graph like this as well. Like create one copy for each vertex. One of them contains a hots, one of them does not contain a hots. For the copies which do not have a hots, use the regular weight W. For copies which have a hots, have weight W by 2. And for all the places where you have a hots, you add a 0 edge so that you can go from without hots to with hots in 0 time. And at last you will have to take care of, like you reach some vertex with the hots, without a hots, so on. Like the reason why we need without a horse is, let's say a graph is like this: 1 to n, only 20, 2, 3, 4, and only these vertices have a horse. Then you will reach from 1 to n without a horse. So that's the reason why. And one more thing is, like, let's say you reach vertex 5 with the horse in time 20, and without horse in time 15. It may happen that, like, for example, now you have an edge of length 100. Now with horse will take 20 plus 50, 70 time, but without horse will take 115 time. And so right now, if with horse is worse, it can happen that with horse we can cover up the time later on. And like, this was the idea for problem E. Any questions on problem E before we move on to problem F? 1 second. Looks like one of my sample fields. If we have a horse, distance by 2, v and 1, we will still have a horse. If v has a horse, it will take same time v0, it will not take time. One second, not sure why my answer is failing on the first sample itself. One second. This should be 5, no? Yeah, 5 only. Why is the code printing 0 always? All the values are infinite initially. Line 135. Okay, got it. Thanks. Yeah, looks fine. So I will probably move on to problem F now. Serif defense. Sarek of Nottingham built the camps with strategy in mind. Thus, there are exactly n camps numbered from 1 to n and n minus 1 rails, each connecting two camps, and any camp can be reached from any other. And so, like, whenever you see something like this, you have n different places, there are n minus 1 roads, and you can start from any node and reach any other node. This just means the given graph is a tree. Then it says if the camp I has AI gold initially. As it is now, all the camps could be destroyed by Robin. Sheriff can strengthen the camp by subtracting C golds from each of the neighborhood camp and use it to build a better defense of that camp. So what Sheriff can do is, he initially has n different places connected by n-1 roads, basically a tree. He can make some places a safe place by taking CC gold from each of the neighborhood of that road. Strengthening a camp does not change its gold, only its neighbors. It's important that to make something a stronghold, only the neighbors' gold you need. You don't really need the gold at that place. Or also a camp can also have some negative gold. After Robin Hood attacks, all the camps have been strengthened, survive the attack, and all the other are destroyed. Now all the places where you make a safe place will remain and everything else would be destroyed. It says what is the maximum gold Sheriff can take in his surviving camp after Robin Hood's attack if he strengthens his camps optimally. Like Sheriff, if he chooses some optimal places to make them a safe haven by taking CC gold from all the neighborhood of those places, what is the maximum gold we can still have? Camp A is neighbor of B if and only if there exists a rail connecting A and B. Only strengthened camp count towards the answer as others are destroyed. So like some important examples are there. Problem F says. So like let's just look at some of the example. In the first example, we have node 1 has 2 is connected and 3 is connected. This place has gold 1, this place has gold 3, this place has gold 1, and C is 1. So the idea is, let's make this a safe haven by taking 1 gold from here, 1 gold from here, and overall at the end you will save is 3 here. Another example is same. We have 1, 2 and 3. This place has gold 3, this place has gold 6, this place has gold 3, and we again have C equal to 1. Now the idea is to first make this place a safe place. So this 6 changes to 5. Then make this a safe place. So this changes from 2. This also changes to 2. Then also make this a safe place. So this changes to 4. And overall you will have at the end of the day is 2 plus 4 plus 4, 8. This was the idea. Now the way to do this type of problem is DP on tree. Like there are some really good tutorial over there. Like you can probably check out this or CSES problem set over here. The idea is, let's say we have this tree. We will solve for each subtree. Let's say DP1 U means what is the maximum gold we can get gold from subtree of U such that U is also a safe haven. And DP2 maximum gold we can take from subtree of U and U is not safe. Our idea would be like, let's look at this node U. For this child, it has multiple child. let's say it's safe DPS and DP not safe. Which is safe, and DP not safe is when U is not safe. Now if both, let's say U and C1 both safe, both of them are safe haven. In this case, you should add, like you will first definitely take the gold of for DPS. AU will be taken, and then for each child either add DPS C1 and then subtract 2 times C1. Like, because like whenever C1 is safe, you are taking the gold in C place. So to make U safe, you will have to subtract C again. And because you are also saving C1, you should also subtract U from C from AU as well. So you will have to add this value either, or let's say you do not want to save as. So you should add max of these two values for each child to this DP if you want to save U, and that would be the maximum gold we can get. If we do not want to save U, then we should just add whatever is the maximum gold, whether we want to save C1 or C2 doesn't really matter. We should just sum it up for all the nodes. And like this ends up being a solution here. Like I will probably explain it again. Where is my eraser? Does anyone know how to increase the eraser size? If you are saving U, then each child would contribute. If we are not saving the child, then whatever the gold we have got from there. If we are also saving a child, then we will have to subtract C 2 times. Once the subtraction from U, once the subtraction from the child. Minus 2 times C. Just take max of this value and add it to all the values we have. And this ends up being the transition state for DP on tree. And now you can now if you know the best goal for each child C1, C2, C3 and all, looking at those values, you can find for node U what would be the maximum goal if you make U a safe haven and if you don't make a safe haven. Then you can use this U and another child of U1 etc. to find it also for the parent of U. And at last, if you keep doing it, you will also find the root node. And at that point of time, you can print the maximum of if you save the root node or if you do not save the root node. And this would be the solution for this problem. Now, if we are saving the node U, then we can take, if we do not save the child, we will not even take the value of U as well. And if we save child, 1C for the node U, 1C for the node child here. And if we are not saving the node U, then we can just take Whatever is the max gold if we save child and if we do not save child. And our answer would be if we save the root and if we do not save the root, whatever gives us the maximum. This would be the solution for this problem. Any questions on this before we move on to problem G? Problem D says Milky Days. Little John is little as night in the day. He has known to be, let's just ignore the story. His dairy has n entries showing that he acquired AI pints of fresh milk on day DI. Milk declines in freshness with each day and stays drinkable for a maximum of k days. In another word, the fresh milk acquired on day DI will be drinkable between day DI and DI plus k minus 1 both included. Each day Little John drinks drinkable milk up to maximum of m pints. In other words, if he has less than m pints, he will drink all and will remain unsatisfied. If there are m pints of milk, he will drink exactly m pints and be satisfied, and it's a milk satisfaction day. Little John always drinks the freshest possible milk first. Determine the number of milk satisfaction days for the Little John. So overall the story goes like this. Like there are some days. Let's take one of the examples also. Let's take this one. On day 8, we get 9 quantity of milk. On day 10, we get 7 quantity. On day 16, we get 16 quantity of milk. On day 21, we get 5. On day 28, we get 9. Let's also maintain a current counter how much milk for each day we have. It will be a map. Right now nothing is there. And let's say we start from time t equal to 0. Until day 8, day 7 we will not have any milk because the day is on day 8. Because the first time milk comes is on day 8. So we will do nothing for the first day 7. When we reach day 8, let's put this entry for day 8 in our milk right now. This is the total milk we have. And each day we want to eat 5 milk. Now like there are 3 scenarios we should look at. Next milk will come on day 10. Quantity 9 will last only for at max 2 days. Or probably let's just look at the number of days when we are full. So for this milk we can drink the complete milk until day 9. Five milk until day 9. Until day 8 only because today is the first day. Until day 9 like morning or probably let's say day 8 only until day 8. Next milk comes on day 8. So let's let's say like we eat 5 milk on day 8 we move from t equal to 10 to 9. 1 is our best day so far. And this quantity has become 4 now. Because we want to drink 5 milk over here, we will drink completely 4 over here. We will not have any milk remaining and we will be unhappy on day 9. So now let's move on to day 10. Fresh sample of size quantity 7 came to us. Again, like we can drink complete 5 milk until day 10 only. Next milk comes on day 16. So let's keep using this milk. First, let's drink 5 milk over here and then 9 or basically my main idea is at any point of time, you will have a set of drinkable milks with each counter over here. And you will have 3 scenarios. Find 3 dates. Find day when latest milk expires. Or even before that, we will have 2 scenarios. And let's handle 2 cases separately here. Latest milk quantity is less than m. Latest milk quantity is greater than equal to m. The idea is for this case, brute force to find all the milks all milk to make quantity m. The idea would be just look at the map, largest value, how much quantity it is, take complete if that is less than what we still need and keep taking the largest number. For this case, find number of days, find day until we keep drinking m milk. And the idea would be to make a direct jump over there. And to find for how many days we can keep drinking milk m. If this milk came on day I and remaining quantity is qi, then we can drink it for qi more days. So until qi plus current day, today's date, we will have 3 lower bounds here. Or this milk can expire, so we can keep drinking it di plus k. Or the third case is like new milk, minimum date for new milk. Until one of these things happens, we will keep drinking milk on each day. So we can directly take the minimum date from these 3, directly jump to that date and add that the difference of those days to our answer over here. And like this was essentially the solution. Like split it into 2 cases. One when like the latest fresh milk we have is less than m, brute force it and only jump by 1 day. And if latest quantity is greater than m, then we can directly count for how many days we can continue drinking m milk there. So the idea is like let's say milk, we have 1 counter milk yet to come, for which each day is count for how many days we that come. We also maintain drinkable milk. Today date Right now, let's say we start from infinity, it doesn't really matter. You can also start from 0. Let's call it good day. As long as our today's date is not until infinity, let's add all the milk that can come right now. So that the first value is less than today's date. The idea is let's add drinkable it in the drinkable milk with date mark on all the days. Whatever quantity came here. And remove this from milk yet to come. Now also remove all the expired milk from drinkable date. So like that would be if it had came on the day before k days before over here. Now let's also find next milk date. If milk is yet to come, like no more milk would be coming, we just say the next date is infinity. Otherwise, whatever is the minimum day over here. And if we do not have any drinkable milk, directly jump from today's date to the day when the milk will come. Fresh milk. What is the quantity of the fresh milk we have? So like whatever milk came at last, what is its quantity? If fresh milk quantity is greater than equal to m, then we will do something. Otherwise, we will brute force on like today's milk, current whatever milk we are drinking so far. As long as we have milk we are drinking so far is not 0. We still have some drinkable milk. Take the fresh milk out. If milk we need right now, if milk we have drank so far plus AI is less than m, less than equal to m, then just add this to our answer and continue. Otherwise, remaining milk would be AI minus the more milk we need. So let's just add this again. If today's milk drank is greater than equal to m, do answer plus plus, otherwise don't do and increase the today's day by 1. If we have more than m milk, expired date, fresh milk date plus k on this date will expire. We can drink m pits up to like water is the quantity by m plus today's date. Directly jumping date is minimum of all the 3 dates, which is whenever the next milk comes. whatever is the expired date and whatever up to which we can print string. And jump date would be minus today. So good days count plus equal to t, and if any milk remains, then we can say drinkable milk for this date would be, there would still be some milk. Otherwise, you can just say remove this date here. And we can keep doing this. The idea is do a mass jump whenever you have current milk quantity greater than equal to m. But if it's less than m, you just brute force here, and this ends up being a solution for you. And we have to also increase the day, right? One second. Okay, why do we have an expiry date? Okay, this should be begin only, right? Okay, this should be X. Okay, 1, 4, 5. Okay. 1 second. Which test case is this failing? 4 tests. 1, 2, 3, 4. So 1 second. Like looks like I messed up somewhere. Quickly, I will just look at in contest submission and see what bug it was. Next milk date is milk yet to come up to this, up to current date plus k, current date plus k, and whatever is the quantity by m, current day plus quantity by today, current date quantity by. Next jump date is minimum of this. Number of days would be difference of these two. Add this to good count. And it's a subtract t star m. And we can directly assign next date as jump date over here. No need to do plus 2. Maybe we have some issue with the brute force. Milk tank is less than m. Drinkable milk is not empty. This should be our beginning. We should always bring the fresh milk. Okay, 1 second. Does anyone see the bug here? Whatever is available and whatever we want to do. This should be an equal to 7. We should not subtract it. Whatever remains would be the remaining milk over here. Okay, the answer is still 5. I will debug for 1 more minute and then call it a day if I do not find a bug. Okay. Eight plus 2 multiplied 2 and maximum multiplied. This should first increase the taken count. Yeah. So this was problem G. Any questions on problem G before we move on to problem H? Okay, problem H says Sheriff of Nottingham has organized a tournament in Archery. In the final round, Robin Hood is playing against Sheriff. There are n targets in round numbered from 1 to n. When a player shots target I, their score increases by AI and the target I is destroyed. The game consists of turns and players alternate between whose turn it is. Robin Hood always starts the game, then Sheriff, and so on. The game continues until all the targets are destroyed. Both the players start with a score of 0. At the end of the game, the player with most score wins and the other player loses. If both the players have same score, it's a tie and no one wins, no one loses. In each turn, the player can sort any target that was not shot before. Both play optimally to sort the most possible score. Sheriff of Nottingham has a suspicion that he might lose the game. This cannot happen. You must help Sheriff. Sheriff will post Q queries. Each specifies L to R and the game will be played on target from L to R. All the other targets are removed and we have to determine will Sheriff lose the game or not. So few critical things here. Like let's say first assume the complete array. Let's say this is the array we have. Sheriff, like it's Sheriff's turn. What should he take one of the elements so that his overall score is maximum? I would claim like each player should always take the maximum possible value here. So for example, when it's Sheriff's turn, he will take 12. Like first it's Robin Hood's turn, he will take plus 12. Then it will be Sheriff's turn, he will take whatever the remaining maximum is. Then Robin Hood will take plus 6. Then Sheriff will take plus 4. Then Robin Hood will take plus 4. Then Sheriff will take plus 2. Overall score here is 22. Overall here score is 16. And by now if you try different permutations, you will notice that Robin Hood can never lose. Because like let's see the turns happens like this. Robin Hood, Sheriff, Robin Hood, Sheriff, Robin Hood, Sheriff, Robin Hood, something like that. Let's say both of them have equal number of turns. Robin Hood will choose maximum. Sheriff will choose second maximum. Robin Hood will again choose third maximum. Sheriff will choose fourth maximum. Robin Hood will choose fifth maximum. Sheriff will choose sixth maximum, sixth largest number. And in each turn you can see Robin Hood chooses value greater than or equal to what Sheriff chooses. And if there is again a Robin Hood chance, then also like Robin Hood will get maximum value and Sheriff will have nothing to take here. So like Robin Hood can never lose, but there can be a draw, and draw happens if maximum is equal to second maximum, third maximum is equal to fourth maximum, fifth maximum is equal to sixth maximum, and so on, and there are even number of elements. That is the only case when there can be a draw with the Sheriff and Sheriff should print, we should print yes, otherwise we should print no. So our problem reduces to Check if every number appears even number of times. And like, we don't really need Moore's algorithm here. The idea is like there is something we can use some hashing here. Like my idea is like for each number in input, I will assign a random integer. Like let's say we have 1, I assign something random, let's say 10. There is 2, I assign something 16, random number. For each value in input of AI, I will assign something random. Like, so like for all the 2's values would be same, for all the 1 values would be same. Then my idea is, if the XOR of these random number is 0, then there is some chance that all the number appears even times. Like if this XOR itself is not 0, then like the numbers would never be equal. Generally, like it's known as XOR hashing. And this was essentially the solution. I think someone in the chat asked like he took the XOR of all the numbers. That doesn't really work. Because if you see, if your numbers are 1, 2, 3. Now let's put something here. 4, 5, 6, 7. This XOR is 0, but it's a losing position. But if my idea is like if I assign a random number to this 4, let's say 100, this 5, let's say 150, this 6, 170, this 7, 200, and if I look at XOR of this number, there is some good chance that this XOR will not be 0. What I know is like if this XOR is not 0, then all the numbers definitely does not appear even number of times. Because if a number appears odd times, that random value contributes to XOR. And if like basically the idea is like A XOR A is 0. So if all the numbers are 0, then whatever random number I take for each number, the final XOR must be 0. But alternative does not hold. Like if this random number XOR is 0, it's not necessary everything was even. But the idea is like for like you use 2 different numbers, like basically use a number from 0 to 128. And the probability that there would be a collision would become very less over there. For that you can use 2 integers, 2 random integers. And essentially this is the solution for this problem. This is XOR hashing, you can probably read here. And I will show my code as well. I am maintaining 2 numbers for each edge and XOR for each number. Take I read input. If I have not assigned any number to X, assign a random 2 numbers to this. And then take prefix XOR of these random numbers. Now you have queries from L to R. So if prefix of L minus 1 is equal to R, it means that everything, the XOR of these numbers from range L to R is 0. So print your subtract print now. And this is in fact the solution for this problem. Any questions on any problem? I think I have discussed all the problems. So I will probably call it a day if there are no more questions from the chat. And thanks everyone for joining here today. no stray nodes. So any questions from the chat? Like, I think I will take something. Like for C, it is possible to apply a binary search. Like you can take it as an homework exercise. My point was like we don't really need a binary search. The binary search solves the problem, but we don't need it. Okay, I just started DSA. What are the basic tips? Like, my idea is like you can probably check out the Discord server. There is a link in the description where I have some beginner advices on what probably people should do. Like you can probably check this roadmap to red, which is a clickbait channel. Obviously, one cannot become red in 2 minutes. So the advice are few bit generic, like start from ABCs. They contain some standard problem. If you are looking at some standard problem on topic X, you can either refer to USEF guide or CSES problem set. There is a book and details as well. Like USEF guide contains some topics related, like bronze is due 3, platinum is due 1.5, silver due 2, gold due 2. So probably if you want to practice some due 1 problems, there are many topics here and each topic has selected problems as well. So you can probably pick one of these and call it a day. Like there is only one advice, like I would say, like can't solve problem up till D. The idea would be to refer editorial, try to solve it. Like there is one famous advice from Umnik: to get better at X, you should do X. So if you can't solve D, like you should try to solve D as a homework problem. Then only you would be able to solve it in context. So like this was all from my side. Any more questions from people in the chat before we call it a day? Like I think I will end the stream now. Thanks everyone for joining today. Okay, negative distance in Dijkstra, like generally like in C++, what we have is max priority queue. So either I write a custom function so that the top value at the top is the minimum value, because in Dijkstra we need the minimum distance, right? Or what I do is just multiply all distance by -1. So the maximum value multiplied by -1 would in fact be the minimum value. Like anything for complete beginner, you can just check the Discord server. There is a channel, roadmap to red in 2 minutes. I have beginner advices here. No, like I am trying, but how can I become better at DP? I know practice is the key, but I want to know something extra. Like practice would only be the way. Like probably you can check out like USEF guide and CSES problem set to practice some standard problems there. Like you can refer some problems here which are related to DP. CSES also has a lot of dynamic programming problems. You can probably start from here. So that is all I have. Thanks everyone. And I think I will end the stream now.